Okay, we are finally ready for our first fundamental theorem of calculus, which is really not that much of a theorem for us. It's just going to be a tool that we use, and we're going to use it a lot. And it's really not that complicated either. The part that's complicated is the part that's coming next when we actually have to do this algebraically. But for now, I'm just giving us our theorem, which is just a tool that we're going to use. But if we have some definite integral from a to b of f prime of x dx, so if we have some derivative function, that is going to be equal to our original function, f of b, minus f of a. Our original function value at our upper bound minus our function at our lower bound. And what is this actually going to look like? Well, we're just going to do a couple of example problems just to sort of get the hang of it, and this should be a pretty short one because this theorem on its own doesn't do that much until we have gotten our next piece, which is algebraically finding integrals. And that one will be more of a doozy. Okay, so we have a table, selected values of the twice differentiable function, f and its derivative, f prime, are given in the table above. What is the value of the integral from 0 to 6 of f prime of x dx? Well, this is just our fundamental theorem. The integral from 0 to 6 of f prime of x dx is just equal to f of 6 minus f of 0. And what is f of 6 and what is f of 0? Well, f of 6 is 2. What is f of 0? F of 0 is negative 22. And that's going to be 24. And boom, that's the value of the integral from 0 to 6 of f prime of x. One other thing I actually want to give notation-wise, because I've been harping on y'all for capital F's. Actually, no. I can save it for later. I am sorry. I'll save it for later. The capital F's are coming. What we use capital F for is going to come up in my next video. Okay, and then our next piece, let g be a differentiable function such that g of 4 equals that and g prime equals that. What is the value of g of 1? Well, we have, this one is a little bit trickier, but what tells me that I'm going to be using the first fundamental theorem is the pieces that we're given. We are given g of 4, and we're given let me pause. Do we actually have the pieces that we need to do this? I might have to change this question. Oh, okay. Okay. Actually, no, I don't need to use a calculator. Or I do need to use a calculator. I don't need to change the question because we are going to use a calculator. Okay. So, what I was saying, the pieces we have g of 4, we have our derivative function, and we have g of 1. So we have two bounds, b and a, and we have a derivative function. So let's write our fundamental theorem. This is going to be the integral from 1 to 4 of g prime of x dx equals g of 4 minus g of 1. Okay, and well, we have g of 4, and we want g of 1, so let's actually rearrange this a little bit. I'm going to solve for g of 1. So what I'm going to do, I'm going to subtract g of 4 from both sides and divide by negative 1. I'm not going to show the work for that. I'm just going to show you the end product. That's going to be g of 4 minus 1 over 4 g prime of x d of x equals g of 1. And it turns into that. Alternatively, you could also add g of 1 to both sides and subtract this integral from both sides and then flip it, and it gives you the same thing. Okay. And now we're asked for the value of g of 1. We have g of 4 is 0.325 minus our integral from 1 to 4. And I'm going to substitute in g prime now. G prime is our 1 over x e to the negative x of cosine of x over 100. This is not something we will ever be able to integrate. In this class, I'm not even sure I would, even with all the tools I have, I would know how to integrate this function because it looks really complicated. But what you can be doing is screaming at me because I forgot something. I forgot my dx. So what we're going to do is we are going to find a way to use a calculator to get this. So we're going to go to Desmos, and I'm going to get myself to Desmos, and then I'll come back when I have Desmos pulled up and I'm ready to give it. So you can go to Desmos now. Okay, I have Desmos, and I know what tool I need to do. So I'm going to end up just typing this whole thing into Desmos. So 0.325 minus, to get our integral, if we go to functions, and we scroll down, it gives us our little integral symbol. And we're integrating from 1 to 4 of 1 over x times e to the negative x times cosine of x over 100. And if you'll notice, it gives us a little error right here because I'm missing my important thing, and it's saying our integrand must end with an integration variable like dx. I'm missing my dx. And then it'll pop in and it'll give us our number, and this tells us that g of 1 equals 0.109, going to 3 decimal places, and I don't round because this is a 4. And boom, that gives me, let me sync it. That gives me that g of 1 equals this. And that's really all that I want to talk about right now with our first fundamental theorem of calculus. We can rearrange stuff, and we can find, we can integrate using this property. And that's all I need to say here. Thank you for watching.